Part A, calculate the value of minus 2 times tan minus 120. That's just us putting that into our calculator, and we'll get minus 2 root 3 in its exact form. Part B, on the same set of axes, sketch the graphs of y equals 2 sine x minus 60 and y equals minus 2 tan x in the interval minus 180 to 180, showing the coordinates of the points of intersection with the coordinate axes in exact form. So let's start with the 2 sine x minus 60. I'm going to draw the basic sine graph first. Then I'm going to deal with the minus 60 part of this, and then I'll times it by the 2 afterwards. So the basic sine graph starts at 0, goes up to 1 at 90, back down to 0 at 180, and then down to minus 1 at 270, and so on. So that's the basic sine graph. Now this minus 60 on the inside there, that's going to take that graph and it's going to add 60 to all of the x coordinates. So it's going to move 60 degrees that way. So let me take this blue curve and we're going to move it 60 degrees. So it's going to move to 60 degrees there. The intercept here would move to be 240. The point over here would move to be minus 120. And we do need to mark on the coordinates of interception. So I do need to mark on this coordinate here. That's where if x was 0, I'd have sine of 0 minus 60. So sine of minus 60 is minus root 3 over 2. Right, we now need to deal with the 2 at the front. That's going to multiply all of the y coordinates by 2. It's going to stretch the graph by a scale factor of 2 in the y direction. So my y-intercept that was at minus root 3 over 2 is now going to be at minus root 3. The maximum and minimum points are now going to be at 2 instead of 1. The roots won't change. The y coordinates here, here and here are still all 0, so timesing those by 2 will still be 0. So it's still going to go through those same points. So it's going to look something like that. I don't need this bit of the graph here past the 180. So there we go. That's my graph of the 2 sine x minus 60. I also need to draw the graph on the same set of axes of minus 2 tan x. So let me just draw the basic tan graph first, and then I'll multiply that by minus 2. So for the basic tan graph, I'd have an asymptote at 90, at 270, at minus 90, and minus 270. And the tan graph would look something like this. Now, if that gets multiplied by the minus 2, that's multiplying all of the y coordinates by minus 2. So it's going to get twice as big, but also flip. It's going to be a reflection in the x-axis. Where the y coordinates were positive before, they're now going to become minus 2 times that, so they're going to become negative. And where they were negative before, they're now going to become positive. So it's now going to look something like this. And then again, just remember, we don't actually need the bits. The less than 90, less than 180, minus 180. Or greater than 180. And there we go. I've drawn both of those graphs on the same set of axes. And I have marked on all of the coordinates of intersection. So yeah, that's part B of this question done. Part C. Explain how you can use your graph to identify the solutions to the equations y equals 2 sine x minus 60 plus 2 tan x equals 0 in that interval. Well, I'm comparing this equation here to what I've just drawn. And I can see that that's basically saying where these curves intersect. If I made the two curves equal to one another, that would be saying the 2 sine x minus 60 equals the minus 2 tan x. That's where the curves would intersect. And then if I add the 2 tan x to both sides, I can see it would equal 0, which is the equation we've been given here. So it's explain how you can use your graph to identify the solutions. It's where the graphs would intersect. And part D, write down the number of solutions. So how many solutions actually are there? How many times do they intersect? Well, I can see they intersect once clearly here and once again over there. So there are 2 solutions between minus 180 and positive 180.